After the product rule, there's the addition rule. I'm only going into giving you the names for these, by the way, because occasionally the textbook will do that, and you'll be like, what's that talking about? Okay, I never actually say oh, use the product rule, right? You just think, okay, these happen together. In what kind of situation would I say use the addition rule? You can probably guess by the way I've set it up. It's when events are not simultaneous, when they don't happen together, okay? So instead of a question like this, the probability of getting two heads, suppose I ask you, what's the probability of just getting two different faces? Good morning. Okay, now you can see there are two different ways to get different faces, right? You flip once, and I've got, whoop, my arm is too round. I've got tails here, okay? So if I get tails first, then I want a head after that, okay? So there's one possibility. What's the other alternative? If I didn't get tails first, if I got heads first, then I'd want tails second, okay? So now have a look at these different options here, and I'll get another color out. I've got this as one of the favorable outcomes, one of the events I'm interested in, right? But then I also have this, okay? Now these can't happen simultaneously. You can't get a head and a tail for the first event both at the same time. You get one or you get the other, okay? So for non-simultaneous events or separate things that can't possibly happen at the same time, you can't get a head tail and a tail head because they're mutually exclusive, right? That's when you add the probabilities. So we still know that each of these is going to be a quarter, but in order to get both of them together, right, you go one plus the other. That's all they mean by the addition rule, okay? So a quarter plus a quarter, that gives you a half. No problems, easy. Okay, one more. The complement. Now, the complement's simple. We know in geometry a complement means something, right? But in probability and set theory, complements mean something else. What does it mean in this context? If I said, for example, let's go with this, right? There's an event. What would be the complement of that event, and therefore what would its probability be? So you might remember, we use this kind of wiggly sign, a tilde above. Number one, what is it? And then we'll work out its probability. The complement just means everything else. Everything else. You know, what's the probability of this not happening? Okay, that's what the complement means. So if you like, you could say it's the opposite event. Or the event not happening is a more technical way to say it. Okay. So it's the probability of this not happening. Now we know that the total probability for all of the outcomes when you add them all up, if you've got the entire sample space, it's equal to 1, right? A quarter plus a quarter plus a quarter plus a quarter equals 1, okay? So therefore, if I add up all of the things that aren't this, it'll be 1 minus that, right? It's like I've got the whole probability now, and I just punch that hole in the corner, okay? Take out a quarter of the running, so 3/4 is the probability of not getting two heads in a row. And there's my 1, 2, 3/4, okay? So the probability of a complement, right, where you can have any event you like, is equal to 1 minus the probability of whatever that event was, okay? Now in this example, it's kind of trivial because there are so few options, right? But sometimes the wording doesn't tell you it's really obviously a complement, right? And sometimes it's much easier to work out the opposite. Example, what if I said, what's the probability of getting the same side? Okay, now the language of it doesn't imply that it's a complement of something else, but it clearly is. What's it the complement of? Getting the different faces, right? You're either getting this or this, right? I would have made it obvious if I said the probability of not getting different faces. But you see, this is part of what makes probability as a topic, probability, that you need to see that these two are the same, or if you like, say that these two are opposite, they're complements, okay? Now, like I said, because it's trivial, right, you might as well just add them up. You can just go this one and this one, it's the same. But sometimes Number one, you'll have already worked this out, so you might as well use it. Or number two, it'll be much easier to calculate the complement. So do this instead, right? And you get a half, just like you did before, okay?